Hello dear students, this video is all about antennas. Here we will try to cover principle of antennas and gain pattern. Before moving into the topic, let's recall what you have learned before. Antenna can be simply called as an aerial. Antenna can transmit or it may receive the signals in the range microwave, or it may be a RF waves, that is radio frequency waves, and it may transmit or receive satellite signals. Further, antenna converts electromagnetic waves into two, that is cable bounded waves and free space waves. At transmitting end, the conversion is from cable bounded waves into free space waves, and at receiving end exactly opposite of it, that is free space waves into electromagnetic waves. So let's move further for principle of antennas. Principle of antenna, that is reciprocity. So here we will try to minimize the burden of telecommunication engineer. We would like to work on this different patterns of antenna that can exhibit identical impedance, that can have identical directional patterns, and it has the same effective height. Means same antenna can be deployed at transmitting or at receiving end. If it is not happen, then we have to design antennas that can transmit the signal only, or it may receive the signal only. So it will be the hectic and a complex issue for a telecommunication engineer. Transmission and reception antennas can be used interchangeably. It must be a linear, medium must be a linear, passive and isotropic. That is, physical properties are same in the different directions. Here word isotropic is included because every practical antenna has to be compared with isotropic antenna, which is the theoretical antenna. Without this comparison, no radiation pattern can be decided. Antennas are usually optimized for reception or for transmission. Antenna is very much important for a satellite communication because we would like to launch the satellite far away from the earth's surface. So we need to design an antenna which is a lesser in weight and which is more directional. So antennas are one of the key elements in a communication system, since their gain values directly determine the amount of received power, because amount of received power will decide quality of signal, that is quality of the service. Ultimately we would like to serve the user with better quality. So here antennas means their size and structure are perhaps the easiest to modify from a hardware point of view. Again, reciprocity is the ability to use the same antenna for both transmitting and receiver. That's why generally antenna is called as transceiver. So how to make an antenna that can transmit and receive the signal? So here the electrical characteristics of an antenna should be unique, should be same for transmitting and receiving. Means we are not designing an antenna especially for receiving and especially for transmitting. The more efficient an antenna is for transmitting at a certain frequency, so the same should be for receiving. There should not be any confusion. We are designing the antenna for transmitting and receiving. No, we are designing the antenna for both, and antenna should possess same characteristics for transmission and reception. So here the reciprocity principle is illustrated in the figure. Case A is for transmitting antenna. When an antenna is used for transmitting, maximum radiation should occur at right angles to the axis. Maximum radiation. So all electromagnetic wave which is coming from transmission line should be radiated via this media, so called as antenna, into the space. So the conversion is cable bounded waves into free space waves. In next case, for receiving, the same antenna is used for receiving over here. Its best reception is along the same path, that is at the right angle to the axis of the antenna. So maximum reception, that is conversion of free space waves into cable bounded waves. So how an antenna can be decided? It is decided based on its radiation pattern. Rather, we can say antennas are described by their gain pattern. We have two kinds of angle, that is azimuth angle and elevation angle. Azimuth angle is represented by phi z and elevation angle represented by phi l, which indicates how the gain of antenna is distributed spatially with respect to the antenna coordinate system. So these gain pattern are often displayed in terms of single planar angle, which is called as phi. So over here we can say this is a major lobe and these are the side lobes. So we should try to see where the electromagnetic wave is concentrated, where the power is concentrated. It is in the major lobe. And where should power should be minimized? In the minor lobes. And if you compare different lobes over here, back lobe has minimum power as compared to other lobes. Minimum power back lobes, side lobe has slightly more power as compared to back lobes, and front lobe or a main lobe is having highest power. So this is called as beam width of an antenna. Beam width is a measure of an angle over which most of the gain occurs. So this is the highest gain, and side lobes amount of gain in off axis direction, because ultimately this lobe will going to serve the user. That's why this lobe is having maximum gain. So side lobes should have minimum amount of gain in the off axis direction, that the gain should be minimum. So this is all about this video. Thank you.